Seriously, one of you guys want to hold that while I'm cranking it? No, I meant hold it, like not hold it to ground, like literally hold it.
Yeah, no, I'm holding it.
No, like
he means hold the tip.
hold it, yeah, just hold it.
Do it.
Wait, this isn't really the best idea. If you had a pacemaker, for sure, this would be an issue.
It's not that bad.
No, clearly, if there's any spark at all, you'll feel a little bit. Even on a good system, all he's going to do is jump. Let me just be clear about this. This is not a troubleshooting procedure. This is something that maybe will be funny and on camera. That's it. That's all we're doing right now. So I'm gonna crank it, and maybe Tom's gonna jump. Maybe he's not.
It's a good thing he signed that waiver.
It's a good thing he signed that waiver. Okay, so a little intro here. I'm not sure why I'm doing it like this, but I am. We are at Latour's Auto, and I brought my whole class with me today. And I am not naming everyone's names on camera because I'll butcher that.
Darius.
But Darius, that's all you need to worry about.
Darius.
Anyway, just wanted you guys to see them. So we're representing Rosedale Technical College, and yeah, so we have 4 cars we're working on today. One's a Nissan with a no start. We have a Dodge truck with a start stall, a Mitsubishi Eclipse with a no start, and then a Dodge Journey with an intermittent no start. So we have our work cut out for us. I don't know which ones you guys will see first, but at some point in time, these will all be up in probably 4 different videos. So intro with the class, we're gonna start with the Nissan. Let's do it. All right, so what are we working on first? What is this? This is a KA24DE engine, which would be a 2.4 liter. And what year is this?
96, yes.
All right, so we're working on a 1996 Nissan, was it Altima? With a 2.4 liter engine. And the issue is it doesn't start, so I'll just let you guys hear it first. I don't have anything connected to it right now. All right, I want to point something out on the dash. As a quick tip, this is something we talked about a few times in class. And when you have a vehicle with a no start, one of the things you need to consider is the 5-volt reference circuit, the computer, is it alive? And so I'll use the check engine light as a guide and into telling me that. So just key off, key back on, make sure the check engine light lights. That doesn't tell us everything, but it is a guide. One more piece. If you have a tachometer like this and you have a no start, crank it and watch the tach. You see the flutter of the tachometer? It's very subtle. The fact that it's bouncing tells us what? What do you guys think? What can we maybe assume is there? What does that tell us about this?
Crank signal?
A crank signal, very good. Chances are, with that slight bounce, it's very slight, chances are we have a good crank signal. I'm not totally sure about that yet because it was hardly moving at all, but it is something to pay attention to. It helps to have this many people around me right now because certain senses that I didn't catch, one was Kendall smelled fuel in the back of the vehicle while I was cranking it. Is that a good guide?
Yes. Oh, yeah.
The fact that you smell fuel tells us what about potentially fuel pressure and injection pulse?
Might not be there.
You smell fuel tells us it is there.
Oh, it is there.
Does that make sense? Mm-hmm. Think about it. We smell fuel out of the tailpipe.
Oh.
Chances are our fuel pressure is there and injection pulse is there. And all of this stuff we need to confirm, but these are all things we can use as guides. Does the check engine light? Does the tachometer bounce? Do you smell fuel? So, I mean, the next easiest things on this car would be to check spark. It's a distributor engine. It's right there in front of us. Why not do it? And it would really just be using a test light connected to ground, check for spark. I don't have a scan tool connected to this. We could go that direction too, but let's just keep it low tech and see what we got. Let me grab my test light. For this part, what I typically will do is I will not connect the test light to the battery. And the reason that I don't want it there is I know that I'm sending those high voltage sparks through here. And just in case I had an air gap or poor connection at the battery, I could also have an arc there, and I don't want to blow the battery up. Not that that would happen in most cases, but just to be safe, when I'm checking for spark, I never go to the battery. I just go to some other piece of metal on the car, okay? My coil wire is this one, And then as far as spark goes, well, you know what? In this case, it might just be easier. Like if I was by myself, I would do it probably this way. Sometimes you modify what you're doing based on who you're with. That's enough of an air gap. That's a pretty wide air gap actually. And we're talking about maybe a little bit more than a half of an inch. It should, a good coil on any system should jump that kind of air gap, okay?
Yes.
I'll crank it. You guys watch, tell me if we have spark. My guess is we're not going to. All right, so no spark there. I wouldn't immediately go toward no spark. Let's make sure and narrow the air gap a little bit, because that was a pretty wide gap that I gave it. Because it didn't jump the last test, that does suggest we have an ignition problem. In fact, everything's pointing toward that. We can smell fuel, but let's narrow the air gap anyway, just to get an idea of what this looks like. Tell me what you guys see, okay? All right. Anybody feel like holding that while I crank it?
Yeah.
Who's getting zapped?
Randy.
Sorry. Seriously, one of you guys want to hold that while I'm cranking it?
Yeah.
Wait, hold on. We got to get this on camera.
Randy, you holding it?
You're supposed to put your tongue on it.
No, I meant hold it. Like, not hold it to ground. Like, literally hold
Yeah,
it.
no, I'm holding it.
No, like,
he means hold the tip.
hold it. Yeah, just hold it.
Do it.
Do you trust me?
That's how I did the Jeep.
Okay. This isn't. This isn't really.
Look away.
Wait. This isn't really the best idea. If you had a pacemaker, for sure, this would be an issue.
It's not that bad.
No, clearly, if there's any spark at all, you'll feel a little bit. Even on a good system, all he's going to do is jump. Let me just be clear about this. This is not a troubleshooting procedure. This is something that maybe will be funny and on camera. That's it. That's all we're doing right now. So I'm going to crank it, and maybe Tom's going to jump. Maybe he's not.
It's a good thing he signed that waiver.
It's a good thing he signed that waiver. Maybe he'll jump. My suspicions, he'll feel nothing. Okay?
Let's hope I hope it's okay.
The suspense was worse than anything, wasn't it? Okay. So we have no spark. So let's think about this for a second. Should we put everybody on camera for let's think about this? No.
No, we could just shout out.
We could just shout it out.
Darius over here.
Okay, well, listen. Listen. We have no spark. Just name me some options on things that could be causing no spark. The coil itself.
Wire.
I heard a cap rotor. The reason why in this application the cap and rotor is not a concern is if you look at where I'm testing for spark.
It's the only one not on it.
I'm testing it right from the coil. Okay? If, I like that you said that, if I was testing for spark in this location and there was no spark, could I have a cap and rotor problem? Yes. Absolutely. So think about what you're doing. When we're checking it directly from the coil, a cap and rotor is not a concern. Make sense?
Yes.
The flip side of that is, what if you were doing a no start like this and you check for spark in this location and you saw spark and you said to yourself, my vehicle has spark, and you start chasing fuel? That would be a mistake, because
It's only one wire.
you could, that's the coil wire, you could have a cap rotor problem where there's no spark coming out and there's spark going in. So do you see where it can mess you up with distributor engines? But the fact that we have no spark here says cap and rotor is not an issue. So coil is one. Keep going. What else?
Like use a relay.
A fuse or relay, so no power to the coil, yes.
Coil wire open.
An open coil wire here, we would definitely have heard some cracking, some buzzing. You would have gotten electrocuted in some way, shape, or form. So I don't expect it to be a coil wire, but that's always an option.
How is that grounded?
How is it grounded? You mean the spark itself?
The block?
Or the coil itself? Oh, okay, good question. The grounding of the coil would be done through an igniter or the computer itself. One of the two, I'm not totally sure. I think an igniter on this one, which would be where, I don't know. A wiring diagram will answer that. So an igniter, where it's grounding is a good one. The igniter or computer itself. Keep going. There's one or two more. What?
Crank sensor?
Crank and cam sensors. Okay? Yes. So our initial tests, the tachometer bounced and the tailpipe smells like fuel. What's that tell you about cam and crank?
They're relating.
It's probably good. Does that make sense?
Yes.
All right, the cam and crank on this engine, it helps to know systems and designs. They're both right here. It's done through an optical, it's called an optical distributor. Right on the side is where my cam and crank signals are. We can check those easily, but I don't want to start there. Where I want to start is right at the coil itself. Tom, who else was with you on that Jeep with the bad coil earlier this term? Philippe. You guys, when you check that, I had you check for coil control. That's exactly where I'm going. I want to see what that coil looks like. And it's just an easy test. It's right up top, and that will answer where we're going next. In fact, what we could do, I was going to break out the Pico. We can stay with the test light. This is a procedure I teach. This is one that anyone can do. Test light connected to ground. I want to make sure my light lights touching battery positive. Okay.
Oh, that's so really.
I have the key on. I'm just going to back probe the coil itself. I'm using, to be clear guys, do not use this method with an LED test light. You will burn out your LED test light for this test.
Too much amperage.
Here's what I'm looking for. When we do this test, we're going to look for coil control. And by control, I'm saying one of the sides of this coil should blink on and off. When it blinks on and off, what is happening is the igniter or computer, whatever's controlling this coil, is turning it on and turning it off. And what that creates is very large voltage spikes, upwards of 300 volt spikes. That's what will cook your LED test light. This is an incandescent. It can handle it, okay? So the first check is to measure both wires with the key on. And you see they're both lit like they should be. So how is one of you guys mentioned fuse, wiring, power to the coil. How's my power to my coil? Good. Variable here, Chrysler systems with the key on, engine off, there will be no power on the coil because the relay that controls power to the coil is the same relay that controls power to the fuel pump. And so you won't have key on, engine off power. Just a little side note there.
Is that why you have to do the bidirectional control?
That's why we did the bidirectional on that Jeep. Very good, Tom, because there was no power there initially. That's normal on a Chrysler. So we have to be careful with this test. But on this car, standard procedure with the key on, both sides of that coil should light. It does. Now the next step is to crank it, and one side should flicker, and the other side should stay steady. Okay? So that's what we're looking for. And I think I can see that light from inside. Let's see what that one looks like first. It dimmed a little bit, right? What made it dim? Amp draw starter, very good. There was no control on that wire at all, okay? So the next one, and again, this is without knowing a wiring diagram or anything, this is just standard procedure. This one should look different. What did we see?
Flickered.
Okay, so the fact that we're pulsing here and we have no spark tells us what?
Distributor. Or it's good up to the distributor.
My coil is right here. I have control. There's pulsing.
The computer's good.
Everything's good. We're done. What do we need? Careful in your answer. You're on film. Think about it. We have
beer.
We have beer? Not yet. It's early for beer. It's only like 10:30.
Aw, speak for yourself. I thought about the answer there.
It is beer time though. On this car, it's beer time. I mean, this is money in your pocket. Talk about what I told you guys. This is off-camera type stuff, but we're on camera. This is $70 in my pocket. If I'm charging my regular fees on this car, yes, very good, Randy. This car needs an ignition coil. We're done. Do you understand that test? I'm going to follow this up with the scope. I want to show it to you on the scope because I think it's important. But that test alone, the fact that this test light's flickering on and off and there's no spark says the module or igniter or computer, whatever's controlling the coil, is doing its job. It's turning on, turning off. It's grounding the circuit and it's letting go. Remember, when we ground an ignition coil, that's when current flows through the primary. We charge the winding. And then when we let it go, we get a spark, a spike in the primary that induces into the secondary. That's where our spark comes from. This is a bad ignition coil. Questions? Make sense? You sure?
Yeah.
I heard a oh from Shane.
Yeah. Well, whenever you were saying that it was flickering,
Yes.
I had the impression that it was good.
That the coil was good.
That the coil was
Gotcha.
good.
No, that's a good point. The flickering says the control
Is
of
good.
the coil is good.
So that's the input of the coil, or that's the output?
Output, because the coil's an output.
It's just not doing its job.
Yep, it's just not doing its job. So what you'd have, Shane, and the rest of you, is you'd have power coming in on this wire. That's why this one stayed steady when I cranked it. That's my feed wire. So power comes in on this side, runs through the primary winding and comes back out, and it's waiting for a ground that occurs at an igniter, a transistor, ignition module, whatever's controlling that coil. And so it's ground side switched. This would be section 3 material. You know, we're talking about ignition systems, which is not section 3 material, right? Output solenoids and transistor drivers is what I titled that chapter, but this is exactly that. It's a ground side switch circuit. So see if this makes sense. Ground side switch, we'd have 12 and 12 if we measure this coil, wouldn't we? With the circuit off. And then when we ground the one side, what's that one side do? It goes down to 0, which is what makes the test light flicker when it turns on. In fact, let me go to the control wire now. When that light goes out, that's when the coil is being grounded. Because what am I connected to? I'm connected to ground. Why is that light lighting right now? It's going through a low ohm coil that does not have a ground. Okay? And there's very, very little voltage drop occurring on that circuit because it's a low ohm coil. So my light's just as bright on the ground wire as it is on the feed wire. Okay? So when the ground occurs on the coil, my light then goes out. Momentarily goes out as long as it's being grounded. And then when the module lets go of the ground, the light lights back up again. Why was it so fast? Why was it just a little flicker? Why didn't we see distinct?
Because the pulse width is
Very, very good. It is a very, very, very small pulse width. You're talking 4, maybe 5 milliseconds of on time between.
by the time it's off, it's on again.
By the time it's off, it's on again. That's exactly right. It does not take time at all to charge this coil, and that's why the light would flicker and not pulse on and off like you would expect a ground side switch circuit to do. Good questions. Make sense? So let's follow that up just with 2 quick scope measurements, a low amp probe, and then the coil primary control itself, and then I'll explain this a little bit better on the computer screen to you guys, and then we'll be done with this one. What I did off camera is I split the conduit back so I could get the jaws of my amp clamp around it, and as far as amperage goes, it doesn't matter which wire I go to because current flow is the same. I just have to make sure that I'm only on one of the 2 wires. So setting my amp clamp on a 20, and I'll just go, to prove a point, I'll go on the feed wire. Let me get my arrow right. Arrow on the amp clamp points to conventional theory current flow. I set this to a 20, and I'm going to go on the feed wire. I think the feed wire was the one to the right, guys?
Yeah.
Right.
Yeah.
So I'm on the feed wire with my amp clamp, and then my control wire, the one that pulsed, was the one to the left, okay? For the primary voltage, you have to be on the control wire. The feed wire will just give you battery voltage as far as a waveform goes. If you want to see coil control, you have to be on the control wire. So that's where that one's going. And I have amp clamp, doesn't matter. Again, now we'll go over to the scope. One last piece is for the blue trace right here. I'm using something on my Pico, it's called an attenuator. And what that does is that steps the voltage down by 10. The maximum input I can put into this Pico, this model, is 200 volts. If I go higher than 200 volts, I can damage my scope. So what this gives me the ability to do is step that voltage down by 10 and protect my scope. I just have to tell my scope that I have one of these in that channel, otherwise the voltage scales will be wrong. Make sense? Everything is times 10 now on that scale. All right, let's go to the scope. I need to set my scales up. I apologize for this. This is not ideal. Channel 1, which is my blue trace. I need to tell it that I'm using my 10-to-1 attenuator. You see it? Sorry. Or am I using 20-to-1? What did I say it was?
10 to 1.
Did it say 10-to-1 or 20 on the attenuator? It says right on it.
20 to 1.
20-to-1?
Yeah.
Okay. Did I say 10?
It's a TA010 is the number like the.
But it says 20-to-1
It says 20 to
attenuator?
1.
Okay, my fault. No, the reason I was confused there, guys, is they used to not have the 10-to-1 attenuators. It used to only be 20. So this is newer software. It's a 20-to-1 attenuator. And all that does for me, guys, is it scales it for me. See the minus 100 to 400 is my range. And so what I've done on my left scaling is it's really not that high a voltage, but it's calculated now, and the two pieces match each other. So whatever I see on the screen will be actual to what's on the car. If I didn't set it to that 20-to-1 attenuator, my scales would be all wrong, okay? All right, so we're good there. And then channel B is my amp probe. I'm just telling it that I'm using my amp clamp in the 20 amp mode, the 60 amp clamp in the 20 amp mode. And then we don't want to have any kind of trigger set here right now. So no trigger at all. I should have two lines on my screen, my red and my blue. And time base wise, 50 milliseconds won't be bad. 5 amps, I'm going to change that to 10 amps. Voltage wise, we're good. Questions on the setups on that? So why is my voltage so high on the coil primary? Because typical coil primary collapse of voltage is around 300 volts or more, okay? And then my scaling for the amp probe, typical coil current is under 10 amps for an ignition coil. Some of this will be experience on what to set your scope up to. You know, initially when you guys are doing this, you're gonna have questions about scaling, and it's gonna be as simple as, well, get the picture on the screen. You know, play around with it. Can you crank that for me? We should be good. All right, 1 second. I'm going to increase my time base here so we see a little bit more of that. And then I'm going to take my sample rate up to 2M. Go ahead and crank it again. All right, that.
They overlap 1 second.
Hang on 1 second. Your foot's not on the gas pedal, is it?
No, it's on.
All right, crank it one more time. Okay, that's good. And honestly, we only need to see one of these. Did you guys hear the little skip in compression on that last crank? That was a little concerning. Doesn't change where we are right here. We could have very well flooded a cylinder. Cylinder wash is a concern.
That's going past the ring.
Yeah, for sure. And that's because we're spraying fuel in these cylinders, and it's not a good thing actually to keep cranking it for where we are right now. But what you're looking at, you see the blue trace and the red trace. Let me zoom in on this for a second. If you were using just the scope and not the test light, there's things you want to pay attention to. You can come out here, Tom. Okay, the scaling for my blue trace, let me get a cursor in there. At that point right there, that's 11.1 volts. That's, see where I put the line? The dotted line across the screen? I know it's hard for you guys to see. That's telling you that your battery voltage to that coil is good. And then where it drops down, I'll put in another cursor for you guys, which is right here, right at that cross point. See where I put the other cursor? What happened with the blue trace at that point is that's the circuit being grounded. This is a ground side switch circuit. So you see where the voltage goes from 11.1 down to near 0. And at the same time that that happens, here, we'll get a measurement of that too. I'll just move that line down. What's that voltage? 1.4 volts. Okay, voltage drop. Is that 1.4? Yeah, there might be a question there with some people is, why didn't that pull all the way down to ground? Well, look at your amperage. Let's get a measurement of amperage on the red trace. If our concern is a poor ground, would a poor ground support 4 amps of current flow? No. 4 amps is actually low for the coil on this, but here, let me back up. Where that switches is the circuit being grounded at that cross point when we go to from like 11.1 and we're dropping. Yeah. And it's not pulling quite down to ground, but it's pretty close. And then the remainder of the period of time where it's low would be our dwell time for ignition systems, or pulse width, if you want to call it that, the amount of time it's being energized. And it's exactly coordinated with the red trace, which is my amperage, isn't it? Ground side switched. When does current flow begin? When we switch it to ground. That's why the red trace starts at that point. And then where does the circuit turn off is where the red trace ends and where the blue line increases. And you see the spike of that blue line? It's kind of off the screen. It's hitting over 380. What's that number? 382 is the top number on my screen. That blue spike, it spiked over 382 volts. We could measure the top of it, but it's not important. You understand that that's what I'm protecting my scope from, is that spike, why I put the attenuator in here. Okay? But what makes the spike is the collapse of the primary field. We should have spark on this coil, and we don't. Why? This coil has a shorted secondary winding. I want you to pay close attention to the initial turn-on ramp of this. That's that one, right? See how it's got this kind of straight up line right here? For you guys later when you watch this, if you want a refresher, I'm going to put on this screen another picture of what we want to see on that initial turn-on. And this will be from section 22 that we're going to be covering together. So chapter 22, I'll pull a picture out of my book from that and I'll put it on here when you watch it later so you know what to look for. Remember this too when we go over it. I'll mention these turn-on oscillations, what we're looking for. This is a classic view of a shorted secondary winding. There's a lot of theory that goes into that that's not very well done in this format. I need my big smart board and things that I can draw on and stuff with you guys, which I'll be doing with you. Okay? Yep. The last piece for this would be to say that, well, there's two more things really. One, I want to mention, I will put in this video for you guys as well, descriptions and other video links of other control testing that I've done. One was on a Subaru, one was on a GM. There was another one, I can't remember the vehicle offhand, but I'm doing the exact same procedures on no spark conditions on other cars. The Subaru I'm thinking of was a bad igniter. And so it'd be worth you guys watching those. I'll put those links in this video when this one's done. And that's for the rest of you paying attention too. Read the description of this video. There'll be other links to related videos. Make sure you're doing that. The second thing is what? What did I want to tell you about this? The second thing would be these coil turn-on oscillations. I'll put a picture, like I said. Actually, you're looking at it now. And that's section 22 material that we're going to be covering together. And if you want to get a jump on it, you guys can actually watch it. It's already there in a playlist listed as chapter 22. You'll be able to hear it twice. So what I'm telling you is it's already been recorded. You can watch it and learn from it. And then when we do it in class, we'll have it down. I guess final comment would be the test light's all we really needed. But you can see with the scope too, that just looking at this tells you have control as well. The amperage pattern, the voltage pattern says we have control, says the computer, igniter, everything's fine. Also tells us what we expected, the cam crank signals on this car. Remember the tachometer bouncing? Never had to check them. The fact that we smell fuel also tells you cam and crank was good. Computer can't fire the injectors without a cam crank signal. You're not going to see a tach bounce without a cam crank signal. You're not going to have coil firing without cam and crank signals. So do we need to check them? Absolutely not. Coil control is there. This is a faulty coil. And in this case, again, that is a shorted secondary when you see a line like that. Okay? Any questions? Good? All right, that's one. All right, being that we were able to stick around here and do some other cars today, we had time to get a coil and prove our diagnosis. And I should bolt this up, but just given time frame here, I'm not going to. What I want to do first is redo our cranking test, because this engine is going to be very flooded, and so it's not going to start right away. It's going to run horribly, and I think the better follow-up is to show you the spark test again. Ready? You can only hear it? You didn't see it?
It's arcing.
You saw it?
It's arcing.
So do I need to do it a couple more times so in case the camera didn't see it?
You want me to hold it this time?
Do you want to hold it this time? No. Here. No.
I watched it arc off then.
Okay, good. Then I'm just going to plug this in and we're going to hear the car run, and I'll bolt up the coil off camera. Cool? Now what we need to remember about a vehicle like this with a bad coil, how much fuel are on these spark plugs. It may not start right away. So I'm not going to panic if it doesn't start. Or if it's a sticking in gear.
That goes on video.
At first I thought your tripod was done.
Oh man, that scared me for a minute because I thought I was in neutral and I wasn't.
That's alright. None of us got hurt.
All right, so that final shot of the vehicle running, that's for all you naysayers out there that say, I get these comments sometimes like, well, we never saw it run, so how do we know you made the right call?
Yeah.
And listen, here's the issue.
Don't let you run us.
Oh yeah. Here's the issue with that though, for what I do, and this is for you guys that don't know, and maybe the first time you're seeing one of my videos. I do mobile troubleshooting. I tell the garage what to do. They pay me for that, I leave. I'm not here for the repair. So I wouldn't have a job if I was wrong. And I especially wouldn't have a job if I'm shooting videos that are a bunch of crap. You know?
Yeah.
Somebody's gonna know, somebody's gonna call me on it. I guess the last word is you just need to trust me in what I'm saying. I'm not giving BS. Okay, I may not always have the final, okay, here's the car running, but I've proven without a shadow of a doubt what I'm telling you is wrong with the car is. In this case, it was nice to be able to put the coil in. You saw the spark, the car runs. Yay us, right?
Yeah.
All right, so if this is a regular day back, guys, if this is a regular day back before I started videoing and of course making money off of YouTube and stuff, this is 3 different cars, 70 bucks a car. That's $210 if my math is right. Is that right? 3 times 7?
That's 21.
$210 for 3 cars, and it would have taken a fraction of the time because you got the camera rolling and we're teaching, explaining. I would have been here an hour tops for 210 bucks. How's that sound? Does that sound pretty good?
Yeah.
Remember, channel 1 was set to my 20-to-1 attenuator. Channel 2 was my current clamp in the 20 amp mode. And then I don't remember the time base that I picked. I was set on a 2 mega sample rate. I think I put this at 200 milliseconds if my memory serves me right. And we had it cranking, of course, because the car didn't start. In this case, we're gonna run the car just because we won't have to crank it.
Did you put that 20 to 10?
I did, it's already in there, yep. We got waveforms on the screen.
Yeah.
Yeah, huge numbers, huge numbers. Forgot to set my scale here. And my amperage is off the scale. That's 5 amp. Let's go 10 amp. All right, so the only difference now, guys, is this is a running picture of it. And we'll just focus in on one of these. We could do a cranking one too, but there's really no need to. Notice the difference in the characteristic of the shape of the current pattern. Do you see the other one had an arc that was going, if you follow my mouse, it went this way and then over that way, remember?
Yeah.
All right, and then the secondary spike looked totally different too. The other thing that you'll notice, the amperage is much higher. This is a 7.2 amp. However, there were some variables to that. We were cranking the engine over, not running the car. So battery voltage is higher, where our battery was weak cranking it. So those numbers might be a little skewed. I almost want to retake it cranking to give you a better after. You know what I mean? Because this is now running.
So just pull
Well, I could do that, or I could, what would be the easy way to keep this thing from running? Yeah, we can pull the fuel pump relay. We'll do that because it's right there. We'll get a cranking shot of this here in a second. Can you crank that for me, John? It's probably gonna, it'll run and then, I should have saved that other picture. I'm mad that I didn't.
You ready?
Yeah, go ahead. Crank it again. Okay. Let me get over here and get that picture now. So this will be cranking. Go ahead and crank it. Okay, good. Totally different looking characteristic with it cranking. Much longer dwell time is what you're looking at there. Right? There's your after cranking picture. Wait, let me retake this one more time. I'm gonna set a trigger because I wanna do, we're gonna do a good before and after. We'll go repeat. Channel A. I'll put it right there. Go ahead and crank that for me again. Okay. File, save.
You're talking shit, but this is the same as your car.
Okay. And
Put a lowering kit on it and there you go.
can you 2220. One more time. Can you crank that for me, John?
Yep.
I'm gonna set this to a different time base. I want to get a really good before picture. Go ahead. Hang on. Go ahead. Okay. No reason to wish. Yes. Feel like a kid in a candy store.
I can't believe how long
That journey was pretty smooth.
All right, we know this coil is junk, so I'm putting the old coil back in to give you guys a good before and after. And then get this wire back on there too. So reinstalling the old coil so we get a good before and after. I saved that one. All right, go ahead and crank it. Perfect. We will save this one.
Oh, that blue one. The end doesn't have any spikes.
This is bad coil. We're gonna talk about this one in class tomorrow. You guys okay with that? Here, I'll show you another nice feature of this Pico. Here, come here, John. Watch this. This is sweet. So if I go to Tools and I go to Reference Waveforms, I'll take channel A. Wait, let me get rid of this one first. I'll take channel A and double click it. Take channel B, double click it. Turn them both on, okay? Press OK. And then what I'll do is I'll open the good one. Whoops. That's not the good one, that's the bad one. I'll open the good one. And I will show my reference waveforms of my bad one. And now we can talk about them. Let's get our zero lines connect where they need to be. And you see the blue trace behind it is that one, right? So maybe I'll separate that a little bit so you can see that, well, no, we'll leave it there. The straight up line right here is suggesting shorted secondary. The amperage is much lower too. Not totally sure I can explain why the module would be limiting the current the way it is. It doesn't like it though, for sure. And then if you look in this area, what you notice is the blue trace. This line right here is called your spark line. That's feedback from the secondary. That's actually the spark leaving the coil. What do we notice that we're missing? There is no spark line. It's gone. It's not there. Cool? Before and after.
I like the Pico. That's what I like.
The
It's more
Pico's
like-
awesome,
it's more
man.
like software than hardware.
Oh, the Pico is a phenomenal tool. All right, so that is it. That concludes our Nissan one. Guys, we will talk a little bit more about this tomorrow. So any questions you have, think about it. This will be maybe the beginning of lecture tomorrow. So glad you guys are here.